Students, good morning. Students who are in the online, am I audible? Okay, so let's start the discussion now. So I hope in the previous class, we already completed the concept of what? INV. What is the next? Come on. What we did already? Date and next solve off. Solve off. We discussed that part. Why are you going there? Sit there only. Friend, who is your friend? Who is your friend? Stand up. Stand up. Friend, not a friend. You are going and sitting along with him. He said he is not a friend. Friend, and you are going and sitting with him. She is not a friend to you. What are the attributes in ND array? Come in. What are the attributes in ND array? Come on, fast. Sit down. Will you sit? Huh? He's a friend. Okay, good. He is not a friend and he is not a friend. Both of them no friends. Over. Matter finished. Python will not contain friends. Only subject. Who is your friend? Python. Very good. Now start. Oh, KVR sir is not your friend. KVR sir is friend outside the door. Inside the class, I am your teacher. Okay? Right. Be careful, students. Shanu, my dear student, I'll move to the further. Some questions I cannot answer, students. Some questions about new courses and all. Some questions I cannot answer it. Answers are there in my third layer of my brain. I cannot answer in the class. Okay, student, and don't misunderstand me. Whatever subject they hand over, I'll 100% justify to my students. That's my nature. That's why I'll come to this. The day which I don't justify, I'll not come to the dais. I'll take rest. Okay, no? That is my style. And even also you need to habituate the same style. And don't misunderstand Shanu, because you asked them something. What about Django class? So I'm not going to respond for that. So don't feel it. So now I'll move to the further. Students, now I'm going to say, now I say, oh, Shanu, yeah, 2 days I said, okay, give me one more day. Give me one more day. That is a day before yesterday you asked, I think so. The second day is running. Okay, now. So let me take one more day, then we'll go for it. Okay, not an issue. Let me enter into the subject. Now, that's what I'm going. That's what I'm entering. Set operations are there. Set operations are available. Very simple for you. What are the set functions I said in the class? Set. Go to Python immediately. Python built on the top of Python. NumPy built on the top of Python. Pandas built on the top of NumPy. And Matplotlib uses both the libraries. What are the functions I used? It just I will open our beautiful class. Any batch you take it. Any batch. You take data types. Under that, data types. Under that, set data type. Under that, you take it. Predefined functions in set. So many functions I said. So many, around 13 functions I said. Clear function, add function. Next is called remove function, discard function. Next is called pop function. And what else? With order, without order. And next is called what copy function, implements a shallow copy. Next is called use disjoint, use superset, use subset. Like that, there is a union, important union. Next is called intersection, difference, symmetric difference. In maths, it is called a delta operator. and a symmetric underscore difference. Of course, that was explained it, maybe sent to you. Update and then problem statement, maybe problem statements and all explained for you. And a combination of what also? Combinations of what also? Problem statement, I said. All dict with the dict, set a tuple, etc. So many things I discussed it. That things will be coming today. Those things will coming today, which an extension only. Nothing difficult for you. You will understand like anything. Let me go to the place, students. Under that, set operations. You only start understanding. Set is a collection of what? Unique elements. Well-defined elements is called what? Set. Sets are used for operations on involving frequent insertions, frequent intersections, and unions under difference operations. Read out. First one itself. Frequent intersections means what? Intersect function. Intersection function. That is nothing but what? You will use what operator? Bitwise or operator, bitwise AND operator. Union, which one you will use? Union function and bitwise OR function. And difference you will use what? Minus. Arithmetic operator minus. Now come on. Create sets in NumPy. We can create NumPy's unique method. Unique method. Unique method for unique elements from an array. Take an example of it. Example, create a set of array, but remember that set arrays should only be what? 1D array. So let us not to worry about that thing. Unique, I will explain here. The function unique says that it takes only unique elements. It takes only unique elements. Let me talk about that. Let me go to this now. I'll explain that, but let me explain about unique. This is also one most useful function. Anyhow, I have to discuss in the class along with set operations. One of my Java student is, of course, he is there in my morning 7 a.m. He was my Java student in 2012. 2012. Now 2024. So now he is in technical manager. Now he said enter into Python level, Python place. And he is there once again in the class, morning 7 a.m. Once again for Python also is coming. So 2012 where, and after working 12 years as a technical manager, again learning Python. So you require, when we learn something, you have to reach to high state. So that is what I expect from you, student. Read the notes well and do the programming more and do the things well. That is my advice. Only coding will make you to understand well. So come to the point. Now I'm going to say import NumPy as what? NP. NumPy as NP. Now I'm going to take up. Here I'm saying NP is equal to NP dot array of take care 10, 20, 10, 20, 30, 40, 10, 30, again 10, and then 15. This is my given data. Print of A comma type of A. Type of A. This is my given data. Suppose I want to create a set. Is it a set? No. I want to create a set with what? Unique elements. Already you know. How do you get it? EAS is equal to, or SA is equal to, set A is equal to, come on, NP dot, come on, what is the function name? Unique. Unique of what? A. Unique of A. What is this unique function will do? Take all the unique elements of what? Yes, ma. Neeraja, today I will send you, ma. Today I will send you. Actually, I want to tell you that zip files now. Zip files I have to send day before yesterday only. But due to some small technical issue that is not uploading that big zip file, today I will upload. There is no doubt in that. Today I will compulsory, I will upload it. Neeraja. Now, np dot unique of A. What is happening? Print of SA. SA and the type of SA. Do you know, students, all these values, unique values, of course, you take something like, you take 20 here. You take something like 10. You take something like 30 here. You take something 30. Like this, you take it. I'm having what, you know, Different order is there or not? When you say this unique, all the elements are coming in what? Sorted order. See that? See this now. We are going to get it in where? According to uniqueness, unique is going to give you the values in the form of sorted order, but it is going to give you in the form of what? Set notation will be taken internally. So here, what is coming here? This value is coming in the sorted order. Is it sorted order or not? So if you want, you can convert later into which type? Set type you can convert. I mean, in NumPy, if you want to obtain a group of unique values, I will apply which function? Unique. So ND array contains unique elements is nothing but it is an ND array set or not? Yes. Come to the next. Did you understand this? One more thing. I will carry the same thing here. I'll carry the same thing. How many elements are there with me? 3, 3 and 9, 10. And I will add one more element called what? Something like, 12 I will add it. Totally how many elements? 11 or 12? 4 and 4. One more element I will add it. That is 20 you take it. Dot what? Reshape of 3 comma 4. 3 comma 4. This is my data, correct? There I want to get it once again. Something like SA1 is equal to NP dot what? Unique. Unique of, I will write it what, A. And print of what again? SA1 comma type of what? SA1. SA1. So you are going to get what? Unique elements from all the rows and columns you will get it. All the unique elements will be coming even from 1D or 2D or ND, whatever it is. It is going to come in the form of what? Flattening. It is not going to give in the form of matrix format because we don't know how many elements are there, right or not. That's why all of them are coming in where? Unique elements. Dear students, you come to forward. Now I'm going to say carry again for 1D only. You go for that. After getting the data, given a ND array, that is given a content of A. Content of A. Now I'm writing content of A. So I'm getting content of A is equal to, already you understood, comma A I'm writing. Now I'm saying something more important. I'm going to say SA is equal to writing A comma one parameter I'm using, return index. Return underscore index is equal to true I am writing. I mean, these elements are present. Right? How these elements are present? 20, 10, and next is called what? 30, and 20, and like this it is there or not? 0, 1, 2, 3, like that it is coming or not? What SA contains? Unique elements. Those elements, unique elements, indexes also will come. Return index is equal to true means what? Duplicate element indexes also will be coming. Are you following? So now I am going to say, comma, what I am writing? Indices also, IND also I am writing. So I am writing, SA I am writing, SA I am writing. Next I am writing what IND also I am writing. IND also I am writing. What are the INDs? Please follow me carefully. Take care ma, here only. If you want, I can write 0. Come on, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5. Now 10 order is coming now. This is an order. What is the order of 10? 10 is there. What is that now? 10, 1 now. And don't think that other 10. Because first one. Next 15. 15 is available in where? 9th. 9th. Next 20 is available in many places. 20 is available in where? 0. This one. 0. Yes. Next 30 is available in where? Second. And 40 is available in where? 5th place. Are you cross checking? Yes. This is called what? Content. unique elements, unique elements, unique elements is equal to comma what? SA. And next what? Indices of unique elements, unique elements is equal to comma what? IND. And this is the content you are getting. Are you getting? Fine. Dear students, same thing you can apply for 2D also, you can apply the same mechanism. For 2D also, you can apply the same mechanism. You try to find out content of this entire thing, content of this entire thing, try to see content of A. Now you try to observe it. Now see this now. We are going to get it what? See this now. Are you able to follow? How this is coming? How this is coming? In this place, there are two things are there. There are two things are there. 10 and this 10. Observe this 10 and 20. Where it is coming? 1 is coming. What this 1 is called? Next. What is the next one is coming? Indices. Next 10 is coming. 12. 12 is there. Where is the 12? You are going to have this 12. You try to count it here. Try to count it. Definitely. This is going to be a 10th element. This is a 11th element. 0 to 11 is nothing but how many? 12. So definitely 1 less than that is nothing but what? 10. Like that, if you count it, you are going to get it. 0, 1, 2, 3, 4, 5, 6, etc. If you count it, you will be getting it. Are you able to follow? Next, online students. Go to the next part of it. Carefully understand. Now I am going to write it. Now I am going to write it. Be careful. That is one thing. Now I am writing return index inverse. Inverse is equal to return index is equal to return inverse is equal to true. Be careful. Be careful. Same SA and this data I am writing it. So here I am going to get it. Please observe, my dear students. No more confusions. What is the meaning? Return inverse is equal to true will give you original array indices. Original array indices. Observe now. What is this now? 0. Careful. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm talking about what? Original array indices. Come on. 2. What is the meaning of? First you arrange the elements. In which order? 10, 15. Come on. 20. Next 30, 40, 40. What is this now? 10. What is this 2? What is this 2? There are 2 is there. 2 times it is there. What is the meaning of 2? What is the meaning of 2? If you arrange this 0, 1, 2, 3, 4, the element 20 available in original index at which place? 20 is available in the sorted array in which place? 20 is available in which place? Second. That is available in where? That is available in how many times? 2 times. This is one place. That is a second. 20 is available. One more 20 is also there. Are you following this? Getting. Next. What is this next? 10. 10. What is this 10 index? The element 10 is available like this. Is available like this. Is available. How many times? 4 times. 4 times. Here also. Are you following? Yes. Are you getting? This will give you unique elements, indices in old index. Are you getting? Actually, without telling also, you don't know. But I'm saying, suppose if I ask a question, I will ask this question. Index return underscore inverse is equal to true. What will happen? It will give you unique elements, indices, number of times in where? Original array. I hope you are following. So this is called what here? Return index. Here return inverse is equal to what? True. That means this data we are returning to what? Original array we are finding it. Comfortable, students? Now take ma 15, you take it 15. After 10, what is coming? 15. So 15. Where is that 15 is available? Where is that 15 is available? 1. That is the last or not? In unique elements, it is available 1. That is present in old this place. It is showing. Understand? This is the return inverse is equal to what? True. Clear? Next, I am going to take up one more. Here I am going to write it. Here I am going to say return counts is equal to return counts is equal to true. Return counts is equal to true. Return counts is equal to true. Start. 10 is available how many times? Yes. The first 10 is available how many times? 15 is available how many times? 20 available how many times? 30 available how many times? 40 available how many times? That is called what? Return counts. Return counts. In my class, boys and girls is a matrix elements. The name called what? Mohan. Mohan is available how many times in my class? When I keep the data in alphabetical order, Mohan is available in my entire class how many times? Mohan name is available how many times in my class? Shannu is available how many times in my class? Or Shekhar is available how many times in my class? That is called what? Return underscore counts. Following? So what is the complete syntax of unique? What is the complete syntax of unique? Come on, students. Unique of what? ARR array. Come on. Return underscore index is equal to true. Return underscore inverse is equal to true. And return underscore count is equal to true. Actually, these are by default made by them as what? False, false, false. Now we are making them as what? True. What is the default value they mentioned? False. They applied a default argument, but we are passing what? True. Are you understanding? Unique. So unique function will create a set of elements or not? Those set of elements, unique indices in the new array, those set of unique elements in original array, those set of unique elements, how many times occurring? That everything is coming in where? Unique. What are the parameters? Return underscore index, return underscore inverse, return underscore counts. Very, very important. Shall I move forward? Yes. So students, this is about unique function. So people will ask you what? How do you find the number of unique elements in ND array? Which function you will use? Unique. Go to the documentation. See students, what I said, just a unique I said. But after that, how many things I got it? Many things we got it or not? So that PDF will come to you. You have to work out on it. Okay. Immediately you practice. After 2 days, 3 days, if you practice now, you will become unique. You will become alone also. So practice immediately so that it will be giving good answers for you. Next, go to where? Finding what? Union. Finding union. Come on. To find the unique values of two arrays, we use union 1D. Union of 1D method. Sir, why only 1D, why 2D? Because we don't know how many unique elements are there. That's why it is going to flatten the list. Understand, ma? Let us take the elements. So we go for this type of array. And nothing is difficult, which is very simple for you. Now I am applying which function? Union function I am applying. And this is left hand left finger for you. Take it A is equal to np dot array of what? 10, 20, 30, 40. B is equal to what? np dot array of what here? 1, 2 and 10, 20. 1, 2, 10, 20. C is equal to what now? np dot what? Union of what? A comma B. A comma B. Print of what? C. And the type of C. And the type of C. So you are getting. So has no attribute. Union of what? So go to the place np dot union of 1D. Yes. 1D, 1D. Yes, 1D. So there also you need to pass it like this. So go to the place A comma B. So you are going to get it. Okay. So now you are going to get it. What are the unique elements? Are you getting or not? So unique elements, we got it. It is called 1D. Even if you take it like this also, try to get it, students. I am writing here like this. I am saying like this, I am applying, and I will take it one more bracket. Here I am writing 1, 2 like this. I am keeping one more bracket, both AB, which is going to be applied something like this. What is happening? Even in the matrix format also I'm saying print of A, and next is what? Print of B, and the print of this. So even the two matrices are available, it will flatten the data. Are you following? Simple, nothing difficult. Union, you got it. Union of what? 1D. Next what? Finding what? Intersection. Intersection, what it is going to give you? Common element present in both the areas. Already you know intersection. What is the function name? Intersect 1D. Intersect 1D. Same array, and you pass it. By default, assume is equal to true. See the parameter argument. By default, what elements it will take? Assume you what elements are coming in sets? Unique elements only. Need not to pass specially the keyword called what? Right. So here one description is given. The intersect 1D method takes an optional argument called what? Assume unique. If set to true, if we set to true, can speed up the computation. By default true only. If you do it, it won't check in the internal argument. That is for speed up purpose we use it. Even you need not to use that also. Directly we can use it. Go to the place. What is the next function? What is the next function? Intersection. Intersection. So I'm going to take it. Intersection of take this data. Take this data. You apply it. What is my function now? Intersect 1D. Intersect 1D. So you are going to get it. Getting this intersection of 1D. And if you go to this place also, intersect of two dimensionals also, you can take it. You can take this intersection of these 2Ds. Same to same. Here I will write. If you want, what is that argument here? Unique is equal to true. Nothing special about it. Nothing special about it. You need not to write. Just something is given. So bracket problem. So take care. And getting this data or not? Last part you see. Last part. So here, last part of it. So here, going to say the data is called what? Same. Same as above also. I did not write assume is called something like this. Easy. Next is called what? Finding the difference. Difference means what? Remove the common elements from both the place and take out the remaining elements from first one and apply. So let us go to that. 1, 2, 3, 4 and 3, 4, 5, 6. Set 1 difference of set 2. What is the answer? 1, 2. Set 2 difference of set 1. 5, 6. 5, 6. Able to follow? Simple. Go to the function now. What is the function name? Set diff 1D. Diff 1D. Have you find out any function in our class diff? Where? Yes, discrete difference. Discrete events time you just find out that. Okay, set this function I will take up. Let us carry this now. Let us carry this data. Here I am going to find out what is the concept. Set a difference. Set a difference. So there I will post it. It's a value and done and got it. The value called what? This part. And next I am going to change your value here. What is this now? Set to 2 comma what? Set 1. Need not to write assume is equal to true. No need to worry about it. Set 2 comma what? Set 1. What will be coming answer? 5, 6 is an answer. Are you following? Like this, one can apply. Able to follow? So, students, I hope you are understanding the meaning of what? Set operations. Able to follow? Now coming to symmetric difference. What is the symmetric difference? S1 symmetric difference of S2. Already I said you in our class, symmetric difference of S2. Remove the common elements from both of them. Take the elements of S1 and take the elements of S2 and kept into where? S3. So that is already we discussed in symmetric difference, which is also one important formula also I said. Union operation and intersection operation formula I said. S delta, S1 delta, that is a symmetric difference of S2 is equal to S1 dot union of S2 minus S1 dot intersection of what? S2. This formula also is set. Even in our Python level, we discussed it here also. What is the function name? See, my dear students, symmetric difference to find out, we are using the function name called set XOR1D. Already we discussed in our problem statement. Problem statement now, XOR, bitwise XOR I said, same thing, bitwise XOR. Bitwise XOR, set XOR of what? 1D. Bitwise intersect operation, intersection operation. We used what? Ampersand. Union operation, we use a bitwise OR operator. These examples I said so many. Okay, come to the point of it. Take this data and print these values here. I am trying to say here, symmetric difference. So, symmetric difference of arrays. Now I am going to say the symmetric difference. Come on, ma, all of you. Assume is equal to true. It's not necessary to write it. Set XOR 1D. What is the symmetric difference? Common elements will be removed. Take the elements 1, 2. Take the elements 5, 6. Put it into where? New array. Try to run this now. What is happening? 1, 2, 5, 6. Got it up? So any difficulty in understanding? Now what are the functions you learned here? Come on, quickly. Unique of, come on. Union 1D. Next, intersect 1D. Difference, set difference. Set diff 1D. Set difference 1D. Next, set XOR 1D. And these are just smart names for our normal set functions. Already you know, union function, all those things you know now. So that are going to be given something, but this is much useful method. Okay, now these are all easy because already we had a big discussion about our sessions. So these are the functions which are present. Set XORD takes an optional argument just to speed up the computation. That's all. Other than that, nothing to worry about it. Are you following? So this is about which functions, ma? Set operations we can call. So, okay, my dear student, Shannu. Okay. Now I will move to the further. So these are called set operations. When some student says like that, my heart little pinching like anything. Really. Shannu, my dear student, I'll take care of that. So come to the point of it. Yes, Mawani, I'll take care of that. Let us move to the further. So VSP Kumar, unique of, union of, intersection of, set 1D, set XOR 1D. So stand up. What is your problem? It's second time, right? Second time. This type of jerks in my class not possible. Go back, stand up, back side. Go there. Sitting in front of me doing feats in the class. Books are not there. Already one time chance, second time chance. Repeatedly doing means garbage collector will collect away. You know our concepts of the classes. KVRC is always giving a fire to the student where you can enjoy the fire. If you keep the fingers in the fire, what will happen? Nothing is there to enjoy. Go back, backside, stand up, stand normally. That's all. Now come to the point back. This is about what function? Come on. Set operations. Now I want to go for continuity of this. I want to say. Next, almost all these things are completed. Okay now? Next, one more thing I want to tell you about our linear algebra. One more thing is left out, I hope so. While I'm discussing yesterday, maybe it is something is left out there. So what is that? A linear algebra place. Dot function, anyhow, you learned it or not? So you learned what? Det. And you learned what? Solve also. Next you learned what? Come on. Inverse also you learned. What is the inverse? You already learned 1 by AD minus BC of that entire thing. D, A minus B minus C. I shown you. Now I want to tell you trace. Trace I want to tell you. Trace. Shall I go for a trace? It is dead easy for you. Trace 1, 2, 3, 4. What is the trace? Sum of principal diagonal elements is called trace. What is the 1 plus 4 is equal to 5. This is some more linear algebra kind of functions. So miscellaneous information. After trace, we'll go for inner and outer also. Let me go for things next. This is about what operations? Examples on NumPy set operations. NumPy set operations. Set operations. Let us go to the next. Another part of it I want to take up. Here, A is equal to import NumPy as NP. A is equal to NP dot array of I say 10, 20, 30. And next I will go for what? 40, 50, 60. And next I will go for what? 70, 80 and 90. Like this I am taking. I hope any extra bracket? Here. Yeah. Here I'll take it. Now print of what now? A. Print of A. Now I want to find the trace. So something like TR is equal to NP dot what? Trace of what? A. If you write it, it will be print that data. Print of what? Trace. Trace is equal to TR I can say. TR I can say. So it is going to print what? 150. Correct? 150. If you, of course, it is very simple for you and nothing is difficulty. And I will go for what? 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, and 0, 0, 1, 0, 0, 1, and A, you print it. And I'll bring the trace also here. And I'll print the trace of the value. Principal diagonal elements you want to find out. You can print the trace. Are you able to follow? Now I want to ask a question. How do you print the reversed principal diagonal elements? This is my question for you. Everybody must answer my question. Take care and apply your intelligence and try to answer it. This is my data. I want to print this data. Ma? Come on. Come on. Come on. Change up. So first you get what? Get these elements or not? Yes. Warning. Advanced indexing. So how do you get the advanced indexing? 0, 1, 2, 0, 1, 2. Tell me now. Silence, everybody. Just come front. If you answer it, you will be sitting here. If you don't answer it, you will go to the back to pavilion. Because when I look at you, I'm getting my school days. No, no, ma, not. 100%. You done first time wrong. Did I say anything? No, no. No more discussion. నేను చెప్పింది వినాలి నువ్వు అంతే. Because KVR sir always speaks facts. When you are sitting here, already you didn't like that, na? Already I looked at you. Did I say anything? No. Second time also doing means what? You take lenience of mine. Sir is my sir. Sir will not say anything. Final is final. That's all. Look at. Tell me the answer now. How do you get this? You are a good student actually, but activity is wrong. Come on. 0, 0, 2. Okay. 1, 1, 2, 0. What is this? Go. Go back. Now I will go to. Now I will go to. Tell me. X is equal to. X is equal to. You stand up. You is your friend. Because of that only he gave jerks in the class. Because earlier, when we were there in the school, when we are going in the school on the way, they used to do something they will touch like that. That's what he is doing, jerking. So both of them are victims in the class. Tell me, answer, you tell me. Concept I don't want, answer I want. Come on, answer. A of square bracket or brace? Wrong. Square bracket only. See, you also doing jerk, he jerking like that, again like that. And both of them are under problem only. A of, come on, 0, 1, 2, comma, braces, 2, 1, 0. Did I say the same example in the class or not? Yes. Print of what? X comma type of X. X comma type of X. Am I getting or not? Now do what? Add them. How do I add them? They're saying when you say girls are, like that. Come on. NP dot sum of which value? X value. See the answer now. What is coming? Correct? 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 What is this is called? Trace of reverse principal diagonal elements. Okay? So able to say properly or jerks? If I call you, if I do like that, what you will feel? Jerks, na? Shido? Both of problem. My time is wasted. Now come to the point. Are you following this? No. This is understandable here. So you have to apply total techniques of what I said. Any problem can be solved very easily. I applied something this type and you got it. Understood? So sit down there only. Now I will move to the further. This is about which function? Trace function you found. Look at ma once again. A of print this A. Once again carry out this and once again carry out this part and here like this. So this is my data or this is the data. I want to find out transpose. So first way to find the transpose. What is that? A dot what? T. A dot T. What is a T? Transpose. A dot T transpose. So A is equal to 2 plus 3J. A dot real. A dot real. A dot IMAG. What is real and IMAG? Attributes. Childhood days. A dot T. Even in NumPy also same terminology. What is A dot T? T is an attribute. In where? A. A. What is an output is printing? It is going to print the rows into columns, columns into rows. It is nothing but transpose. Transpose means rows becomes columns, columns becomes rows. It's nothing. It is already you done in 10th class and all those places. Same or not? Same. The identity matrix transpose is going to be same. Let me go to the another example where you can feel the difference. Where you can feel the difference. This is the way. This is a given matrix. This is a print of what? Given matrix. Matrix A. Matrix A. There I am going to write it. A I am writing. A I am writing. Next I will write it. Transpose of a matrix. Transpose of a matrix. How do you do that? A dot what? T. You write it in where? A. Or something like AT. AT. Because when I wrote A dot T, just only output is coming, original data not modified. You know that, students. Print of what? Transposed matrix, I will write it. Transposed matrix. So, transposed matrix. Transpose of matrix A. Transpose of matrix A, which is going to print what? AT. See, students, is it rows becomes columns and columns becomes rows or not? This row is becoming what? Column. This row becoming like this. Are you following? Right. Still, last and final, one small thing to have more and more clarity. Remove these two, ma. Remove these two. Remove these two. And here I will write it. Print of what? Dimension. So shape I will write it. Shape of what? A, comma what? A dot what? Shape. A dot shape. And the next is called what? Shape of what? Transposed matrix. Shape of transposed matrix. It is an opposite or not? Transposed matrix. Transposed matrix is equal to what? AT dot shape. If it is, what is this matrix here? 2 by 3. It will become what? That's all. So C, students, it is going to be 2 comma 3. It is becoming what? 3 comma 2. Easy? Well, this is called A dot T. First way this is. This is the first way. First way. Second way I am going to talk about it. This is all called first way. This is a first way. First approach this is. Second way I am going to talk about it. Easy, not a difficult. Look at. Second way I am going to talk about it. Comment. First, this also I'll keep it comment. Okay, students. Then go to second way. There I'm going to write it. Here I'm going to write NP dot. There is a function name called what? Transpose. Transpose of what? A. Easy enough. A dot T with the form of what? Attribute. Attribute. NP dot transpose of A. The element A values will become the same. Same output will be coming here also. Are you getting or not? Here also getting. So last and final, this part also I will carry. So there I am writing. Here also. In place of A dot T, what I will write it? NP dot transpose. Transpose of what? A. Transpose of A. So getting the data. Okay now? So how many ways are there to transpose a matrix? 2 ways. One is ND array object dot T. T. What is the T? Attribute in ND array. ND array dot ndim, ND array dot shape, size, item size, like that A dot T. Or one more is what? NP dot transpose of ND array. It is going to be done. Understand? Fine. Next, you see trace, and don't think that it is belongs to linALG. linALG functions INV, solve, det. Remaining, these things are only belongs to. Remaining things are what? As usual, what? Other things only. Other. Trace belongs to NP. Dot belongs to NP. Inner and outer also belongs to NP. There is one more function called rank of a matrix. Rank. R1 tends to R1 minus 2 R2. R3 gives what? R1 minus 3 R2. Have we solved it? You remembered, huh? If you don't remember, I have to make you to become 10th class teacher again. So rank, anyhow, I'll show you one small example. Right now, let me go for what? Dot matrix already I said. For what purpose? Matrix multiplication. Matrix multiplication. Dot, dot. Matmul and a dot. Already we discussed now. Now, go to what? Inner product, inner matrix product. Actually, not that much useful. Just I want to take up inner and outer. Let us go to the inner and outer. Go to inner function of NumPy. NumPy. A is equal to NP dot array of 1 comma 2, 10 comma 1, 10 comma 10 comma or 1 comma 2, no problem. Comma what next? 3 comma 4. Comma what I am doing? This is called one list. One more I will take it. One more I will take it. 11 comma 12. 11 comma 12. One more is 13 comma 14. 13 comma 14. Are you following? These two things I want to take it, students. These are two things I want to take up. This is one thing. Next, B is equal to what? NP dot what? Array of like this I want to take it. This I want to take. This is one more. I'm taking like this. So here I'm going to take up print of, here only I will write it. Just here I will write it. Print of what? Matrix A. Matrix A. Print of A. Next matrix B. Matrix B. Here I am writing like this. Now try to do this. This is the matrix or not? What happens? Both A only printed. B you printed. See students, this is my matrix, correct? Now you go for C is equal to NP dot of A comma B. That is nothing but what? Actual matrix multiplication. Actual matrix multiplication. And how many types of multiplications are there already? That is my intention to tell. Element wise matrix multiplication, A star B, you know na? A star B, that is one thing. Print of what ma? C comma type of C. C comma type of C. Is it an actual matrix multiplication or not? How? 1 into 11, 2 into 12. So every row of first matrix will be multiplied with every column. You know na? Yes. That is about what? Matrix multiplication, which was already explained. One entry I will calculate. 1 into 11 plus 2 into 13. 2 into 13. What is that answer? Come on. 37. Next. Next. What is the next? 1 into 12 plus 2 into what? 14. What is the answer now? 12 plus 28. What is the answer? 40. Like that. That is comes under what matrix? Actual matrix multiplication. You know na? There is a multiply is there. Multiply. Multiply. See. D is equal to NP dot multiply. Multiply of what? A comma B. Print of what? D comma type of D. It is the element wise matrix multiplication. 1 into 11 is 11. 11. 2 into 12 is 24. 3 into 13 is 39. 4 into 14 is 56. 4 into 14. Are you following? So 56. This is called what? Multiply. You can also do the same thing by using which operator I said? Yes, you know that. That's good. So this is also going to be like this. Okay, now come to this part. Already we are aware of that. We are already aware of that. Now I am going to say here I will go for C is equal to or some K is equal to what I am doing A NP dot inner of what A comma B. A comma B. Print of inner product. Inner product of matrix A and what matrix B. Matrix B. Print of what C comma type of C. K. Okay. K and K here and K here. See students, what you got it. And some of the people are trying to tell it is equivalent to matrix multiplication. No, it is not equal to matrix multiplication. It is something different. How it is applicable, you just see. How it is done? 1 into 2, 1 into 11 plus what? Come on. 1 into what? 11. And next is what? 2 into, come on, 13 or 12? 13. What it is going to be? 1 into 11 and 2 into what? 13. How much it is? No. 1 into what? 11 plus 2 into 12. 2 into 12. It is going to be called what? This row multiplied with this row, comma, 1 into what again? 13. 13 plus 2 into 14. 13 plus what? 13 plus what? 28. What it is called? 41. Are you able to follow? Next, be careful. Come on, students. 3, 4. 3 into 11. 3 into 11 plus 4 into 12. 12. What is this is going to be? 33 plus what? 48. What is the answer? Come on. Yes. Next, 3 into 4 multiplied with what again? 13 into 14. It is going to be what? That is called what? Inner product. Getting or not? This is one more product. Suppose if you go to what is multiplication? Somebody ask in Python. What you will say? 2 elements multiplication, matrix multiplication, matrix element wise multiplication, inner multiplication, outer multiplication. If you say to interviewer will say, show me all of them. If they ask, if you show all of them, will they impress about your performance or not? Like that, you need to answer it. Go to the inner product. Dot product already done. Inner product 1, 2, 5, 7, 2, 4, etc. Now I gave you the simplest explanation also here. Inner product. Are you following, students? This is different in where? 2D. It is similar in where? 1D. 1D is similar. 1D is similar. 1D is very simple. 1D means what? First element, second element. First element, second element, both of them. But 2D I want to show you. The 2D is completely different. For 1D, inner and what? Dot is same. But what is different? It is different in the case of what? 1D. 1D is same. 2-dimensional onwards, it is different. If you want, go to back. Here I am going to write it. Here I am going to write it. Carefully try to follow. The same thing I will carry here. Now I am writing. Carefully follow, students. Here 1, 2. 1, 2. Say what now? 3, 4. 1, 2, 3, 4 I said. Here I am writing. 11, 12, something I said. 13, 14 I said. Try to run. Print of what? A. Print of what? Array A. Array A. Next I'm going to say what? Array B. I am writing B. Print A here. Print of A. Now print of what? B. And say what next? C is equal to what? NP dot Come on. Dot of what? A comma B. A comma B. What is this now? Multiplication of 1D. Multiplication of 1D arrays with what function? Dot. You say what next? Dot of what? Print of what? C. Print of C. Now I am writing next. What is the next? Multiplication of 1D with what? Inner. Inner of. I will write it. I will write it. What is this now? D I will write it. What I will write? Inner I will write it. Inner of. This I will write a D. Try to run this. Is it same or not? Same or not? It is going to be same. Able to get, students? So how it is? 1 into 11, 2 into 12, 13 into this one, 14 into 4, 14. Able to understand? In the case of 1D, both of them are same. In the case of 2D, what is different? Dot is different from inner. Clear? Huh? Yes. Be careful. Try to follow. If you do in the middle of it jerks like this, both of them look like same only. Correct? Now, I'll move to the further. Now, I will go to the another one is called what? Outer function. Outer function. Be careful. Here you see. Outer function carefully. Let us see an example. Outer product. 135,246. Careful. Outer to perform what? Outer matrix multiplication. NP dot outer. How it is done? Take care. 1 into 2. Come on, 1 into 2. Each value multiplied with everything and prepare the matrix. 1 into 2, 2. 1 into 4, 4. 1 into 6. Next. 3 into 2, 6. 3 into 4, 12. Next is what? 3 into 6, 18. Are you following? Next, 5 into 2, same thing, 10. 5 into 4, 20. 5 into 6. This is called which matrix? Which product? Outer product. Inner product, outer product, dot product, 1D product. See how many product? Normal product, total products only. So if you take LKG student and 22-year student, what is the product? If you tell all these things, you're really genuine or not? Suppose if I go to an interview, I'll tell everything to show what I am. If you say only A into B, it is only for something. No, you have to explore your total knowledge. I gave the description also, how it is done also I said. Okay now students, let us go for this entire thing. Try to do the outer operation. Outer operation. Go to this place. Here I will carry on. I will take up this data. Here I will take this data. Here I will apply. Here I will say, remove this now. I will apply what? Outer of. Outer of I will apply. Outer of. Multiplication. Multiplication of 1D arrays with what function? Outer of. Outer of I am going to say. See the data. What you have. See that? 1 into 11, 1 into 12, 1 into 13, 1 into 14. 2 into 11, 2 into 13, all these things. Able to follow? Easy or difficult? Who will tell all these things are in interview? If you don't tell, be like that only. So try to improve. And now I am going to take up, carry on. Now I am going to take up. Now I am going to say outer of. Go to this. Now I am saying outer of. Outer of AB. What product it is? Outer product. Outer product. See this now carefully. What is happening you see? Come on here. What is happening here? AB. And the next, start with what? 1 into 11. Come on. 1 into what? 12. Got it. Next what? 1 into what? 13. 1 into 14. Done. Next. Now you got it. 2 into 11. 2 into, yes, 2 into 13. 2 into 14. Now you are very good. You understood. This is called which product? Outer product. How many products? Normal number products. Element wise multiplication. Matrix multiplication. Inner product. Outer product. You know functions correspondingly. This is called a complete meaning of product or not? So coming to the point of it. Vengat Ambadi. Is there any function from left union and right union? So whatever union is there, I already said. Any left union, right union is there, let me know, Mr. Ambati. So now I will move to the further. Whatever I know, I am saying. If Ambati knows anything new, Ambati can say. So that I can tell in the class. I will also learn it. First of all, we have to learn what I am explaining. If anything is there, I will also learn if Ambati says. Correct or not? Because education is always improvement only. Let us. This is called what concept? Product. Now, one thing I want to take it, look into that. 2, 4, 4, 8. 8. This is my matrix. A. Rank of A I want to find. Rank of A. Rank of A I want to find. Rank of A I will find. Come on. So I will write it. You don't know rank of A? No coaching is taken, nothing is there, just taking back and going to home and taking breakfast, lunch, dinner 3 times and not doing anything. Finding what? Rank of what? A. Rank of a matrix. Rank of a matrix. A is equal to NP dot array of, take some matrix, 2 comma what? 4. 2 comma 4. I will take next what? Come on. 4 comma what? Come on. 8. 4 comma 8. So coming to this place, print of matrix A. Matrix A. After going to home, try to find out what is the rank of a matrix. 2 by 2 rank is there. 3 by 3 rank is there. By making something is some rows as zeros and remaining rows unable to make them as zeros. If complete zeros are coming, rank will become what? 2. If 3 by 3 matrix, 1 row becomes completely 0, rank is 2. If 2 rows becomes what? Complete rows become 0, rank is what? 1. So Rk is equal to, Rnk is equal to np dot lin alg dot what? Rank of what? A. So print of what? Rank of A is equal to comma what? Rnk. So here I am going to get it. Some attribute error has no attribute called what? Rank. Maybe it is present in where? NP dot. So here also NumPy module is not having rank. So rank function. How to find the rank of a matrix? NP dot rank of A. So ND array has no object. Ranked 1D. Ranked what? 1D. Okay, my dear student, Raghuram. So NP dot rank 1D of what? A. Okay. So ranked 1D also, rank 1D also, no, it's not working. Rank of 1D, NP dot, so going to the matrix underscore rank, Lakshman Kumar. np dot ling linalg dot matrix underscore rank. Okay. Matrix underscore rank of what? A. A. Okay. Now got it. How you got this now? 2, 4, 4, 8. Even though I'm taking, something is skip off my mind. Rank I am remembering, but actually it is called what? Matrix underscore rank. So you can make this as 0 or you can make this as 0. How can you make this as 0? R2 is 2. What is this now? 2R1 minus 2R1 minus R2. What is the 2R1? 4. 4 minus 4. This 2, 4 remains same. R2 operation. 2R is what? 2 into R1. 4. 4 minus 4. 0. What is this now? 2R1. 8. 8 minus 8. 0. I prepared to write like this. I planned to write like that. That's why rank is what? 1. Suppose I am writing something like what? Something like I am writing 3 and then I am writing something like 5, for example. So what the rank is called? 2 only. Are you finding? 3 by 3 also you take, 4 by 4 also you take it and try to do. Last and final, I'll try to do it. Unit matrix, I will take it. What is the unit matrix? Like this I am taking. I hope you know this. 0, 1, 0. What is the next? 0, 0, 1. I will take it. What is the rank of the matrix? Come on. 3. Yeah, so 3. Rank of a matrix is 3. So this is about with other rows you have to make it something 0. Not possible to make it this. Rank is called what? 3. It is just one. In coaching centers, they will say some tips like this. And you have to remember also. Concept also you have to remember. Yes. So like this, you can do. There is one concept is there, student, that I will explain in separate time. That is called what? Broadcasting concept I want to tell you. Broadcasting concept is also there. That generally I used to tell to the student. Near to the pandas concept, I will explain. Near to the pandas, I will explain. So one topic is left out, that is called broadcasting thing. Let us go to once my NumPy here. So I will go to somewhere else. Maybe. So in this place, index, I will open it. Read out everything. Done. Done, done. Look at on the screen. If you look at me, nothing is written on my forehead. Right? NumPy data types, view and copy, slicing, advanced indexing, slicing, filtering, everything. How to iterate the elements using loops, using NDITR and end determination. Arithmetic operators, simple. Array manipulation, resize, flatten and everything. And swapping accesses also you have done it. Next is called what? Joining multiple arrays, stack, etc. done. Concatenation is a old version of what? This kind of things. And still concatenate if you want, I can explain you, nothing to worry. Splitting of arrays, you know, horizontal splitting, vertical splitting, array split, equal splits, unequal splits and everything. Sorting elements, searching elements with where option I said, where class. How to insert the elements, insert, append, delete the elements, matrix multiplication dot, importance of matrix class in NumPy, INV, matrix power, already we said star, remember or done? Power function. Next is called a det, solve, along with that I said what also? Some extra matrix rank also is set. Now, statistical operations also is set, and a NumPy mathematical function summation, LCD, GCD, all those things, LCM and all those things. How to find out what? Unique items also. This IO operations are also there. There I will explain in near to pandas concept, because something I want to tell you separately in connection with pandas. Okay, now? So I will remember what is the broadcasting I have to explain, and the next is what? IO operation. Okay, now? So this thing, it's very simple. There are 3 functions or 4 functions are there. One is what? save off. One more is called what? Load off. Save off, load off. After that, next is what? Save text. Save text. What is an opposite? Come on. A load text. This is something like what? Files operation. Files. How concept we learn in the files? In our class, files. That much concept we are using in our Python NumPy in a simplest format. Save off, load off. Save text and then what? Load text. So in our class, Python level, if you go to that, files concept if you see, index concept if you see, these are our files. Files first level, files second level, files writing the data, random access files, and pickling and unpickling, pickle module, working with the CSV files, and then this type. That I will use it into my NumPy level also. Because anyhow, CSV file concept is coming in pandas. That time I will tell you saving the data with NumPy. Broadcasting, this generally I used to discuss in my batches during that time only. Okay, now? Fine. So with that, NumPy is completed. Monday class when I am coming, pandas I will discuss. Pandas. So pandas means generally people will discuss outside 1 hour they will discuss and people will become panda. Panda. I will discuss most perfectly this pandas. Telangana government released 10th class results. Which district got more percentage? Which district got less percentage? Who is stand up first in the mathematics? I want to go for analysis part. That analysis part is done by what? Pandas. Calculation and array based computing is called NumPy. Both of them data visualization is called matplotlib. This is what is the concept required. So Monday, what is the concept? Pandas. Panda stands for panel data. Spell out the full form. So anybody ask what is panda? You should not say you are a gold medalist answer. You have to say what is pandas. You have to tell total. What is the NumPy? You tell me. NumPy you understood or? Stands for what? Numerical Python. How much concepts are there? If you tell 1 hour enough for you? No. So you have to describe so many concepts in that. That is called NumPy done. And NumPy will be carry forwarded even in where? Pandas also. Still more interesting than this NumPy I will explain. Don't miss on Monday. So, Viresh, sir, how many days will take for pandas? Actually, NumPy I thought of taking 2 weeks, but almost 3 weeks over. Now, pandas also I want to tell. You want to discuss deeper, up and down, sir? Then don't ask me the time. So, Viresh, you know, my dear student. So, discussing 1 or 2 days, becoming instead of becoming panda, like a Kinder Joy, inside Kinder Joy, one panda will be there. Inside the Kinder Joy sweet, one panda will be there. Don't become like that. Become a legend. Instead of panda, become a legend. Okay, now? So, Monday, we'll go for what? Pandas. Don't become option. Thank you, students. All the best. Jerk you. Do it. Save from circle. Not listening. Waiting. When do you do that? Concentrating and hearing. If you stand up now, Saurav, my dear student,
Hello,
Saurav.
sir.
Saurav.
Yes, sir. Hello, sir. Good morning.
Good morning, ma'am.
Yes, sir. Sir, I have a doubt in some of the function. The first one is assume underscore unique is equal to true.
Yeah,
So can you
actually,
please
yes, sets are by default true only. Assume underscore
okay.
unique is an argument, argument, keyword argument. In our functions we used to discuss in our Python class or not.
Yes, sir.
By default, sets allows what? Unique elements only, na?
Yes, sir.
So that is nothing but the argument says what? Assume unique is equal to true. By default, set allows what elements only? By default, set allows duplicates, unique.
Unique, sir. Unique value.
That's what. You need not write assume unique is equal to true. That means
Okay.
you need not to tell sets to assume unique is equal to true. By default, it is true only. Suppose if you write to true now, it is not checking by itself. It is speed up the computation. It is saying.
Mm. Okay, sir.
Right.
And one more thing is, sir, one more function is a rank function. Sir, can you please explain
Mat
once again, sir?
matrix underscore rank. That is 2, 4, 4, 8, for example. Any one of the row you make it equal to 0 if possible. So R2 this is, R1 this is. R2 elements I can make it 0. How? R2 use, it is at our basic 10th class level. R2 is equal to 2R1 minus 2 become 4. 2 into 2 is becoming 4. 2R1 minus R2. It's a just mathematics awareness. 2R1 is what? This one, 4. What is the equivalent row? 4. 2 into 2 is called 4. 4 minus 4 is called 0. So this is becoming 0. Second one, 2R1 means what? 8. 8 minus R2 is 8. 8, 8, 2, this is becoming 0. So this is becoming 0. Only one row is left out. That is known as what? Rank is 1. Either row you make completely 0 or column you make completely 0. That is called rank is going to be remaining elements. Saurabh, did you understand?
Okay. Okay, sir. Okay, so the rank will be one or zero only.
Total elements are becoming 0. It is called rank is 0.
Okay, sir.
If
Okay,
elements are
sir.
not
Get it, sir.
if elements are not possible to do 0 rows or 0 columns, rank is remaining same as number of rows and number of columns.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Okay, Saurabh. Swapna.
Hello, good morning, sir.
Morning, ma'am.
Sir, could you please explain unique functions parameter return underscore inverse?
Huh?
Return underscore inverse.
That is going to give you original array indexes after getting the unique elements.
Original array indexes.
Original array index. Original array here.
Oh,
Inverse is equal to true here. I hope it is written here. I hope previously. Set operations. Maybe this what? Inverse is equal to true means that is what maybe it is saved under that. It is going to give you in this place only explained. This is set operations different. Set beginning unique here unique is this inverse is equal to true here. It is going to give you that 10 is available in the original index. In which indexes this is available, it is showing. 10 is available what? In the sorted array 0 now.
yes.
Now this is available in
0.
which places?
0. Yeah.
This is available in these places where it is showing. This element 10, the element 10 in original array where it is available, it is showing.
In original array. Okay. Oh.
You try to sit on that and try to keep. I already explained in the class how this is working, how this is visible like. For example, 15 you see. 15 is available in the sorted array in where 1 now. This
1.
is 0,
Yeah.
1. And 15 is there in the last, right?
Yes.
It is placing here. So
Okay.
this is the sorted element index which is available in the last of your original array.
Okay. Indexes are placed in as like original array. Okay, sir.
Yes. Okay.
Okay. Thank you, sir.
Okay. Okay, students, take care. and don't miss the next class, Monday class, very, very important. All the best. Take care.